So good afternoon, ladies and gentlemen. eContext is owned by info.com, and info.com is a search engine that's been around since 1999. And in 2008, I decided that we needed to make more sense of search keywords because we wanted to provide a better experience through our search engine. So I pulled in an engineer and said, how do we actually categorize these keywords so we can make better sense of this? And he disappeared and came back a couple of days later, and he showed me this screenshot, and I said, what's that? He said, oh, that's a thing called natural language processing that's extracted a thing called entity extraction, and we end up with this. I said, well, what is it? He said, it's called a word cloud. I said, a word cloud? It looks like an art project. I can't work with that. So I had a board meeting, and I said to the board, okay, I want to classify the internet. And the chairman said, excuse me, what do you mean classify the internet? I said, well, we've been in search for about 8 years. We have a vast amount of search data, and we've already made sense of a lot of these keywords into topics. He said, well, how long is it going to take? I said, well, I think about 4 years and about 100 people, and it will probably cost about $20 million. And then he said, well, how many topics do you want to generate? I said, well, Yellow Pages has about 3,000 or 4,000, and I think retailers tend to have, big ones anyway, tend to have about 20 or 30,000. So I think we're going to have about 100,000 topics. So away we went, and we started recruiting these people, these taxonomists, subject matter experts, and time progressed. And to be frank with you, the whole thing was a nightmare of biblical proportions. After about 4 years, we actually ended up not with 100 people, but 200 people. And we were up to about 250,000 topics in this hierarchical tree. So we categorized search, and we manually audited 120 million keywords to improve the integrity of the rules that classified this data. So we classified search, and that went well, and then we looked at content, and then we looked at social media. And that was a very depressing day, because despite how good our product was, the false positives in social media caused an immense amount of issues. So we then spent a further 4 years and ended up with 450,000 topics. It took 1 million hours of R&D and 200 people. Anyway, so here I am talking about bots. So because we've, in essence, taken search data and social data and several billion unstructured conversations and mapped that to our 450,000 topics, we've now got a general taxonomy that really understands the needs and interests of modern humanity. So our current product is providing services through our API for people like IAC, WPP, Publicis. So chatbots, why am I here? Well, we all understand that chatbots is going to be big, as you can see from the CEO of Microsoft. He's confident that it's going to be everywhere. But it's about context. Everything about chatbots has to be about context. Absolutely essential. The problem is that there's no magic AI fairy. Despite what you read about AI, accepting that AI is important and plays a very important and growing role, there really is no magic fairy. And as you can see here, the CTO of Facebook thinks that we're years away before we can actually have a proper conversation with a machine. Interestingly, yesterday there was a report out by Accenture which talks about the next generation, the importance of integrating human intelligence with machine intelligence so they can successfully coexist in a two-way learning relationship, this symbiotic relationship between man and machine. So what are we? We believe, the world's largest general semantic text classification engine. So we understand the context contained with any text, regardless of whether it's voice, social, search, news, web pages. And we've probably got one of the world's most diverse, accurate, and structured English language knowledge bases, suitable for multiple AI applications. So what does that mean for us? It's because we have this vast depository of data from social and search segmented to these 450,000 topics, we then do machine learning to train on these data sets within these topics. And because our forte is short strings of text, we can request the machine only to learn on certain types of data. So for example, if you're talking about back pain, and the tweet says, I get back pain when I feed the dolphins at Disneyland, that talks about 3 separate things. So the machine gets a bit confused. I was looking at a page of Wikipedia on soil erosion the other day, and it's not just about soil erosion, it's about other topics, like irrigation, fertilizer, fencing, weather, farming. So the machine gets confused. So we were able to take our data within these topics and narrowly define it within the specific. So in the subject of back pain, if the topic says, I've got lower muscle spasm, I have back pain, I need to see a chiropractor, then clearly they're in the same vertical. So here's a simple example of how things can be miscategorized, taking these words. You can now see a simple example of unstructured text and how we would map that to our category tree. And you can see here, it's the final node and a sample of the last 3. So that just gives you a nice sort of example of how that would work. So to give you an idea of the IP, it maps to every single vertical, which is why it's a general taxonomy, a universal taxonomy. It's up to 21 tiers deep, 450,000 nodes, and it took 1 million hours of human R&D to build. It's very fast. It maps at a rate of 55,000 keywords a second, and it has 55 million rules, 55 million positive and negative rules to understand semantically the context of how we map stuff. We have huge training data sets here. We've got, obviously, because we're a search engine, we understand search and web pages, Twitter. We map for a client in real time the Twitter fire hose, blogs, forums, and also info.com has spent 150 million on search. So we have a very deep understanding of human intent. Other areas that we use, we can map videos, blogs, forums, as I mentioned earlier, basically any other text. And there are a number of applications that our technology can do. So for bot building, we bought a URL called botbuilder.com. And in about 6 to 8 weeks, we're going to launch that as a very simple product for retailers or for content providers. The idea is that if you're a retailer, you don't want the hassle of building a bot and understanding natural language intelligence and how you map those to their categories. So the idea is that they will upload their products and their descriptions. We will then in real time map those products, to give it a category ID, and then when someone chats with a bot, we'll use our natural language intelligence to interpret the correct context, and then we will provide the best results. The objective, of course, is to empower developers to use us, as well as non-technical folks who want to launch a chatbot quickly and easily. So for those that know me, I've been going on about the Yeti for years, so I must come up with another example, but I just happen to quite like it. So the Yeti, the positives for Yeti could be Bigfoot, Sasquatch, the abominable snowman, but the other thing is that Yeti can be lots of things. As you can see here, it can be a microphone, a bike brand, a car brand, a water cooler, and even a crab. So in terms of artificial intelligence and machine learning, if you've got the context of someone's conversation and asks for something, because we are a general taxonomy, we understand the ontological relationships between how people search for one thing, talk about another. Because we have this sequential history of people's search queries, we understand the relationship of what those topics are about. So if somebody talks about Yeti, and previously he's been talking about maybe kayaks or picnic supplies, we understand that the cooler Yeti is probably the best option to provide. And of course, if he's talking about maybe microphones over here, if he's talking about things like pianos or singing lessons or audio recording equipment, then we would provide that as a best result. Because of my history in search, we understand that when you have advertisements, it's based on the click-through rate. Equally, when you have a menu of choices to give the consumer, once you get those voice conversations, you can then alter the menu options to provide with the customer. So I was going to show you live, but I didn't dare because of the internet, but we do have a live demo over there with one of our folks, Chris, here. But what we did is that we connected to the Wal-Mart API, and when someone does a query, we hit the API, we map the product and the descriptions, and we provide the best result. And what you can see below here are samples of the topics that best match I have a headache. This is a simple example. If you put that in headache, this is examples of ontological relationships. And this is also useful from our perspective to do related search queries for info.com. Another example here is, I need lawn fertilizer. And here we have the menu. I think it's really important. I mean, Ted Livingston was saying yesterday about the importance of having a menu option. It doesn't matter what AI you have. The fact is, people are saying things. Often you need to clarify actually what they mean. Therefore, it's essential that they have an option of menu items to select what they do want. And again, here's the ontological relationship of that word, lawn fertilizer. I encourage you to download this white paper. We sponsored it the other day. It was written by a couple of pretty clever professors, and you can see it on our website as well. If you'd like to have access to the Wal-Mart API bot, shoot me an email and we'll give you credentials to do so. Or if you want to see it live in action, we have a booth over here. And that's it.
Stephen Starr, everybody. Does anyone have a question for Stephen? We're doing okay here? One more time for Stephen Starr. Thank you very much.